Okay guys, this is a note on pH. Okay, so pH stands for the power of hydrogen. It's a scale that measures how acidic or how basic a solution is. It ranges from 0 to 14. Now, if a solution has a pH of 7, it's considered neutral, so it's not an acid or a base. So water is a good example of something neutral. A solution with a pH of less than 7 is acidic, okay? And that means that it has a pH that's low, that's below 7. Okay, so some examples are like coffee that has a pH of 5 and stomach acid that has a pH of 1.5. So this is really acidic here. Now, if you have a pH of more than 7, it's basic. So the higher the number, okay, greater than 7, it becomes more basic. So things like drain cleaner and bleach. Now, one thing to point out is if you have a number close to 7, okay, so for example, black coffee and milk, we call this a weak acid because it's closer to neutral, whereas stomach acid and lemon juice would be a strong acid. Then over on the basic side, if you have a pH of 8 or 9, which is closer to 7, this is a weak base, and as the number goes up, it becomes a stronger base. So this is the pH scale, okay? And we use the scale to determine, certain chemicals, their pH, or maybe you might have seen this if you have a pool or a hot tub or know someone that does, because you're always trying to manage the pH of the water. Okay, so if you have an acidic solution, so less than 7, okay, there are a lot of hydrogen ions in the solution. You have a basic solution, so you have more than 7 as the pH, then you have many hydroxide ions in the solution. Now, strong acids and strong bases are both very corrosive and reactive and require very careful handling. Now, an indicator is a substance that changes color depending on what a pH is for that substance. An example is litmus paper. So we have litmus paper that's blue and litmus paper that is red. Now, acids will change the blue litmus paper red, and bases will turn the red litmus paper blue. And that indicates whether it's an acid or a base. So some pH in our lives. pH of solutions can have a huge effect on us, in our bodies, in our homes, and in the wider world. We can solve all kinds of problems through our knowledge of acids and bases. pH and soil is really, really important. It's important to everyone, especially people who grow food, so farmers or people that have gardens. Now remember, farmers feed cities, so pH, we deal with pH all the time. Different plants grow in different pH levels. Some plants grow better in lower pH, while others grow best in higher. Therefore, the pH can sometimes be altered to improve growing conditions for plants. And farmers can adjust the pH. Sometimes you might see farmers or hear farmers spreading lime over their fields, and that's to affect the pH, to bring it back up to a neutral pH if it's gone really acidic. Now, there are metal toxins in some types of soils. Many sites in Canada contain soil that is contaminated with toxic chemicals, and many of these toxins are metals. So what we do to fix that is if we have some contaminated soil, we use acid leaching, which is the process of adding acid to the soil. And what it does, it removes the metals. It breaks them up, it corrodes them, okay, and then the solution drains through. This is not realistic for farming though. We don't want to grow our food in soil that has high toxins in it, like metals. So a better way, if it has to deal with land that we want to grow plants on, is to grow plants in the soil that naturally absorb metal toxins. So things like carrots and root vegetables, and what they do is they absorb all those metals. But they're not good to eat after that. So some farmers, when they do this, they might have to forego a crop for a year in order to remedy their soil issue. So when they harvest them, they burn them, and the metals are recycled from their ashes. So usually you take those say vegetables and you send them off to be disposed of. pH in customer products. Warnings are placed on customer products if the pH is too high or too low for humans to use safely. So for example, our household product symbols or even WHMIS symbols. Shampoo and skincare products have a pH closer to neutral, and that's because if it's too acidic or too basic, it will dry out our skin. Okay, it could even create burns or rashes. So we want to keep it as neutral as possible. Now, pH in swimming pools, ideally readings in pools should be kept between 7.2 and 7.8, just slightly basic. If it goes out of this range, it may irritate the eyes, the pool chemicals won't work as effectively, and there's many kinds of test kits available, but it has to deal with pH. Now, if you have a really basic, so say this number is higher than 8, what you can do is you can add an acid to level it out and bring it closer to neutral. And then you could also add a base if the pH is very low to bring it up higher. Okay, so acids and bases can be added to each other to adjust the pH. We also call them neutralization reactions when we want to neutralize it completely and bring it to 7. Now, smaller lakes and acids from acid rain can be treated with a base to raise their pH to more normal range. So with our pollution, sometimes little lakes and ponds and areas get very acidic, and that's really bad for aquatic life. And so people will add a base to treat the water so it brings it back up closer to neutral so animals can thrive. So that is the end of this note. The next part I need you to do is to complete the worksheet that's attached for today. Now there's a sheet having to deal with the acid and bases note, and so all the answers are in the note and you're just filling in. And the second page is about the pH, so you're just filling it in from the note we just did. And then you're going to submit. Okay. The last thing for today is the Gizmo lab for pH. So if you take a look at that under the tab, I'll have another video there, as well as your exit questions. If you have any questions, just let me know. Okay, we'll see you soon.